Hello everybody, my name is Josef Weilhammer from AMCM and it's a pleasure for me to speak today here at TCT and show you our product portfolio of the startup AMCM. Short agenda, so some words about AMCM, facts and figures, system portfolio and roadmap. So first, what is the name AMCM? It's an abbreviation of Additive Manufacturing Customized Machine. So what do? We customize EOS machines. So AMCM is a company in the EOS group, or better call it Langer Group. So we are independent company next to EOS and Additive Minds and AM Global. We are in this group from the Langer company. Who we are? We are people from, let's say, two sectors. The first group of people is from a laser company, Basel Laser Tech. People work in our team. They have decades of experience in producing lasers and optics. The Basel Laser Tech was sold to Coherent, but the team, the R&D people stayed there in Starnberg. And the other part of the team is EOS people, like me. So I worked 23 years at EOS as application engineer, trainer, and also product manager. And also many others, product owners and product managers are now in the team. Short history. In 2016, so 1 year before, Hans Langer spoke with Martin Bullemer. When do we do the machines what we don't do at EOS? Because they are so special and we cannot do it at EOS. Then Martin said, I have an idea. I have some former colleagues from Basel Laser and we can do such customizing. So then the company was founded in 2017. The first 1 meter part was produced in 2018. Then also the first copper chrome zirconium part 1920. We sold already M290 fine detail resolution, I come to that, and the first M4K. And then rapidly growing in 2021, we had delivery of already 10 machines. And in 2022, we had already funding for M8K and so on. And Enlight was the latest development. So facts and figures. So in the first year, Hans Langer gave money. So a startup is not earning money from the first year, but from second year we earned money. And our story is quite nice, so we had a good revenue. This is our location in the former building of Basel Laser Tech. In Starnberg we have 5,000 square meters of production area. We can do in parallel production of 12 M290s, 4 M4Ks and 2 M450s. So we are very technology driven in our team, so a lot of engineers, product managers, application engineers, and also a service team. We have own software colleagues and also logistic, but the benefit of that EOS group is we can use shared services from EOS. So like IP or also software that comes from EOS. Here a picture of our production site where we can have 4 M4Ks next to it in production. We are present worldwide, so we have installed already 116 systems. So 40 in North America, 57 in Europe, 19 in Asia, and 2 in Australia. And you see it's a mix of metal and plastic machine, mainly metal, but we also do customizing of plastic machines. Maybe a short phrasing of our vision. We do tuning of EOS machine. So you see on left-hand side machines which look outside still like an EOS machine. They might have stronger laser or a bit bigger envelope, but this is what we call tuned. The modification is quite easy and also lead time is quite short. On the other side is what we call customized machines. The machine have more modification and they do not look like EOS machines, or they are bit modified, but this is also a good business part, and today it's about 50-50 share of this range. Also from this M4K system, we sold so far 20 systems. Most of them are in aerospace and in service provider area, and there will be soon also one system installed in Japan. Now to our system portfolio. The beginning of our success story was the M290-2 FDR. FDR stands for Fine Detail Resolution, and the purpose of that machine is with a very fine spot of 40 micron to make fine structures, and especially with this machine basis of EOS with 400 watt laser and finer spots, we were able to sinter and melt very challenging materials. And I come to that. The customer has an application, computer tomography. I think many of you know that device. Computer tomographs need a so-called anti-scatter grid. When you or a patient lies in that computer tomograph, X-ray source passes your body and is guided through these anti-scatter grids on a detector. The benefit of additive-made anti-scatter grid is you can do with less X-ray dosage the pictures, and the additive-made anti-scatter grid produce better detail resolution. So the benefit is for the patient double. You have less dosage during that computer tomography treatment, and you have a better detail resolution. We sold more than 15 systems in the same application, so it's a niche, but this is our business. So that anti-scatter grids are done in tungsten, but the machine can also run stainless steel like 316L or titanium or cobalt chrome. We can supply you also with parameters for these materials on request. The next machine, also similar to EOS, is a AMCM M290 with two 1 kilowatt laser. The benefit is two lasers. It's like with a car, 4 wheels driven, better than 2 wheels driven, more power. So we have 2 times kilowatt on board. Kilowatt is relevant for copper or difficult materials, and we have the same spot size as the EOS M290, so you can also use the experiences done on your M290 history, and definitely you can increase the productivity and reduce the cost per part. And also what I will show, we modified the cooling and the gas flow. It's a bit like in a car. If you equip a car with a strong engine, you also have to increase the performance of the brake or the performance of the cooling, or to increase the aerodynamics. The same is what we do. We put more power on the machine, and then we add additional equipment to bring the power on the street. The M290-2 has a so-called full field overlap. So we have a scanning strategy where you can either make a split line, what you see on left-hand side, or you have a so-called full field overlap, that both lasers work in parallel, simultaneously, and finally the contour is done with one laser. So the benefit is you have really a perfect 50-50 split and the perfect load balancing. So a very cost-efficient, productive machine. So this is what I said. If you tune a machine, if you tune a car, you need some improvements. The main improvements to handle 2 times kilowatt is getting rid of the heat, because 2 lasers with 2 kilowatt produce a lot of heat, especially producing aluminium or copper. So more or less all around the process chamber we add additional water cooling, and we made a special gas flow as well, because whenever you have looked in an additive machine, a metal machine, and you see the welding process, you also saw the smoke. So this is just a side effect of any welding. And having two strong lasers, you just have to improve the gas flow to get rid of these process side products. And here we made a so-called flow box, which is a bit producing a kind of laminar flow to enter a wider flow nozzle and produce a homogeneous gas carpet to remove the gas and the smoke away from the powder bed. Typical materials are aluminium and copper, but all materials which EOS has developed by tool steel or stainless steel are also possible on that machine. We have service providers which use that machine on 1 week, maybe with stainless steel, just using 370 watts. And next week they use the same machine with a maximum power of 2 times 900 watt on powder bed, maybe with aluminium. So that gives you a high flexibility with this machine. The latest product in the M290 version is the so-called M290-2 FLX, FLX for flexibility. As I said, AMCM R&D people have developed laser for quite a long time. We did a cooperation with Enlight, and the result was additive laser. An additive laser which has an additional parameter. You can form the beam. So directly out of the laser, you get different beam diameters. No defocus, no optical lenses moving. So in between 30 milliseconds, you can switch from small beam to big beam. So for R&D people, it's just one parameter more next to laser power, scan speed, or hedge distance. So in index 0, the default, you have a Gaussian beam. This is like today's IPG laser on the EOS machine. And in index 6, you have a donut, which could be quite big. And in between, the sizes between 85 and 210 microns. So it's possible to produce a part, maybe the contour in 85 microns, the in-skin in 210, and maybe the support in 180 microns. The laser has a high power, nominal power 1.2, and in the big mode, we have an effective laser power of 1 kilowatt on powder bed. So very, very high laser power. What can we do? Just to give you an idea, make a head-to-head comparison between an Enlight and the EOS M400. So you see here, you have just 19 hours, 56 minutes compared to 36 hours. So it's 45% reduction of exposure time. So the recoating time stays the same, but in total you have 40% reduction. And just via beamforming, just with one laser. If you would have two lasers, even higher potential to reduce cost per part. But it's not just volume rate. You all see parts here on the show, and you all touch them and you see the roughness. Everybody wants to improve the roughness. It's very tricky to improve the roughness with a very fine spot because it tends in the downskin to overheating. But if you can control in the downskin the energy, maybe with a bit different beam shape, you are also capable to make a better adaptation of the downskin surfaces. So that could also help to improve surface quality. And another benefit, it is not a completely new setup. It's a fiber laser, it's an infrared fiber laser, and in the mode 0, it is exactly a copy and correlate with the IPG laser. So you can use your parameters or the EOS parameters also on that machine. And also the kilowatt parameters, as I said, the machine can even go up to 1 kilowatt from EOS, and AMCM can be used on that machine as well. Another special feature, I showed you the full field overlap. If you have two lasers, and these two lasers have different beam capabilities, you can use one laser as a kind of in situ heating. So one laser can run in front or run behind and do on the powder bed, on the part, preheating. Everybody knows if you have a slim, high part, it's very difficult to keep the temperature level from the platform up there as well. And with a clever combination of OT monitoring, smart fusion, you can make here an additional heating feature to control the best melting in the melt pool. And this is an interesting feature what is possible with full field overlap and with the beamforming. The machine is very much perceived in R&D now. We sold 4 of them. So they like the options that they can play around. Here you see already the EOS print window with the parameters where you can set the index. You can increase productivity. You can play with pulsed laser additionally. You can have pre and post heating. And we also have an option to have even smaller spots if you want. So that is a very flexible machine and interesting for academia, I would say. So AMCM also made some M290 options for R&D. For example, a build volume reduction, where you can use small quantities of powder inside, some people call it minimizer, and that has a water cooling, so you can use demanding materials. And you put that in the machine, you remove these handles, and then you can run demanding materials on a temperature level up to 500 degrees. The platform size is 100 millimeter in diameter, and in C it's also 100 millimeter. Can be removed again and put in as you like. As a permanent option, we also have developed the heating. So the platform size is 240 to 240, but the recommended build area to achieve 500 degree is 220 to 220. The corners are a bit colder. We use the same heating also up to 600 degree, then we limit the building area to 200. For R&D purpose, we also made one machine even with higher temperature. So please let us know if you have a demanding application. We can support you. This is our job to customize machines also with heating. What we learned from a customer case with heating, when you work in a hot process, your powder might suffer if you don't remove the oxygen. So there is a very simple device where you can purify the process gas and remove moisture and humidity out of that, and you can run the process in a condition of, let's say, below 50 ppm, and you can test and produce parts which have demanding properties. Can be also upgraded later on if you want, so that is also sold for research purpose. Now to our big machines. The M454 looks very much the same like EOS M400-4, but we made some improvements. So for sure the envelope is bigger, 25% bigger in X and Y. For sure we had to remove the overflow bin because we have a bigger envelope, and also some additional cooling. And in the optic, we moved the optic a bit that we can cover a field of 450 to 450. Sounds simple, but as you all know, if you want to make out of a car, a racing car, you have to think about some details. So building area is bigger, powder handling is quite easy. Smart coil from EOS is easy to adapt, you just need a bigger platform. But we also added other features which are relevant, like smart monitoring and OT, where you have capability to control the process much better. The N-Light laser, also for that big machine, gives you the capability to be much faster and have higher productivity. Also the gas flow, as I said, if you have more lasers, more laser power, you have more smoke, then you also have to remove the smoke. And that is why we have also an optimized gas flow integrated. M4K is just a bit the larger brother of M450. Many elements are similar. For example, the process chamber of M4K and M450 are identical. It's just a bit higher. So what's the benefit of that machine? It can produce parts with 1 meter height in C, and the machine can be equipped with up to 4 times kilowatt or 4 times N-light, and it has also special cooling in the build envelope, and also has capabilities to run the EOS parameters as well. So 1 meter part for that rocket, diameter, height, ratio, that is a good fit. The machine looks very different from outside, but inside, if you see, there is a process chamber identical to EOS, the filter system identical to EOS, dispenser, software, monitoring. People which can operate the M400 will find just one push button in software, which is different. The rest is identical EOS M400 software. So this is the envelope. The scanner are bits moved to the corners to cover the envelope of 450, but the overlap area is 100 like on EOS M400. Also calibration, same like EOS, just bigger. Just speed up a bit to stay in time. Main material which is ordered from our customer so far is Inconel 718, copper alloys for these rockets, but as I said, the machine is like a EOS M400-4. You can utilize all parameters from the EOS portfolio. Having huge machines, you have to feed them. You have to feed them with a lot of powder. AMCM developed together with Volkmann powder handling options. We call it open loop and closed loop. Just to give you an idea, the longest job ever built on an M4K was 21 days, 3 weeks. The machine should not stop, should not run out of powder, because that is very expensive. So open loop means we have a 400 liter bin next to the machine. That 400 liters are good for, let's say, 2.5 jobs even, so plenty of powder. And whenever the machine dispenser is a bit empty, it asks for powder and gets feeded. We also offer so-called closed loop, where a sieving station is included, and you can more or less pump the powder in a cycle. Most often, closed loop is ordered. Finally, I come to the latest R&D product, what AMCM is doing. It's a M8K. So AMCM got a funding from European Union to develop a large-size AM system, because European Union do not want to depend on North America or others to deliver rockets or to deliver equipment for space. And so we got a funding to develop an AMM machine, which is large size, so 800, and 1.2 meters. It has up to 8 lasers, or it has 8 lasers, and a material which could be processed is Inconel and copper, but also others. But this was what the European Union for that Ariane rocket asked for. This is a demo part, what you also see on the exam booth over there. So it was produced with M4K in 8 pieces, just to show the final dimension of such a part. The machine is, even if it is a big envelope, quite compact. So on the right-hand side, you see the AMCM M4K, which is 6 meters to 3.5 and 3.5 in sea height. And the M8K will end up at 14 meters to 5 meters to 3.75 meters. Quite compact for, let's say, 1.2 meter high parts. And this is what we are aiming for. This is what the European Union is interested to equip their own rockets with these Vinci and Vulcan bell nozzles built in Europe or from a European supplier. Bit of a roadmap. So what we are doing, we are very driven from orders, but we do also some internal development, like now with N-light laser, to have special machines equipped now, M290-1 with 1 laser and N-light, M290-2 with dual laser, also M4K. First machine will also be produced soon. Next, what we do is what I mentioned, the N-Light with a fine detail resolution, spot size 55 to 120. And these pre-development blue boxes end up in new machines. What we are currently doing, we improve the gas flow of the M4K and M450 just to be able to add even more energy and stronger lasers in that machine and to be more productive. And we also get other customized machines orders in. And next year we have also this M8K project and delivery. And we know that there is already M3 and M8 customized orders already in. And then let's see what comes next. We do customize when orders come in and maybe even bigger. The process and the concept of the M8K is capable to go up to 1 meter in X and Y. So if somebody wants to hit that limit, we are prepared. So, thank you for your attention. If you have questions, let me know or visit our booth and come over and we consult you.